Hi and welcome. This time around, I'm not going to focus so much on machining, but it's some modifications and changes I've had in my shop. First off is this hydraulic table I got at Harbor Freight a while ago, and I've actually used it a bunch for moving various heavy items off of trucks that deliver stuff when you don't want to pay liftgate fees. And it's just been a general table sitting over next to my storage cabinet for quite a while. But recently I thought, well, this is kind of a waste because all that space underneath it, all the support structure is being wasted. So I started looking for a 2-foot by 3-foot granite surface plate, thinking I could get a table with a 2x3 surface plate and put it to better use and find some way to use that as my table. And I was able to win an auction, and I got this 2x3 surface plate with the stand. However, the stand's been modified already. So if you look down below, there's these lock-off feet that let you adjust height and some aluminum extension arms made with fairly thick aluminum with solid aluminum plugs in each end that are threaded. The casters are, let's see, what are they? They're 12 millimeter, 1.75 millimeter thread pitch. And the top is, this table came with 1/2-inch 13 thread bolts that you use to level it. And the bottom shelf, which I replaced the wood on because the old one was completely soaked in grease. So to it, I added the middle shelf just to divide that space up. But you'll notice I left a gap on the side here. And the reason for that is I've got some tall items, namely the Square Master, my Michu Toyo, and my Shars height gauges. And these I want to store underneath temporarily, and I just wanted to find a place for them. I've also got a bunch of other stuff that's going to go into there. This surface plate I'm going to get rid of and make some room clearing off my workbench over here by putting some stuff over here. Haven't figured out exactly how this is going to work yet. So going back to the surface plate, I raised it up, and the reason I raised it up is so that this guy that I originally was just going to get rid of, but sort of hesitantly because I've used it so much. Now, it fits underneath, so without wasting any, much more space, almost no space. It's a little bit wider, that's what it is. So I've lost about 4 or 5 inches in my pathway here, which I was willing to give up. So I've got the surface plate, I've got some shelves. Let's see what I can put on those shelves. All right, so first off, disappointing. The Michu Toyo height gauge here is actually about 1/8 of an inch under the bottom of the granite plate. However, it's so wide, I can't lean it over enough to get under the rim. So for now, it's gonna have to stay there. Unless I decide to swap out this 3/4 ply for 1/2-inch ply, then it'll fit. So I've got my other height gauge there, and the Square Master, my granite parallels, two sets. One of my pride and joys, this Suburban Tool magnetic square, cylinder square. And then I have, setting the Square Master, I've got this inexpensive granite square block. And I have a cylinder square here that's used. And I got this one somewhat recently. It's a Brown and Sharp non-cylindrical square, which is kind of pretty. I bought it because it's just beautiful, and the price was right. And I'm just a collector of tools, so I think that one's really nice. So I just thought it would be great to have. Then I've got, in the back, I've got my granite square back there, a standard granite. A couple of big V blocks that don't fit anywhere else. These are my 3-point micrometers and my gauge block sets. And down below are my pin gauges. And I'm sure I can fit more stuff down here. So that one space that once upon a time all it held was a table now allowed me to get all of my metrology stuff, well, all of my precision metrology stuff in one place. I mean, I normally call micrometers precision, but these 3 points are another level up, so I'm sort of calling them that, maybe incorrectly. So I'm fitting a lot of stuff down here that was all around my shop, which frees up some other space here. And I'm going to find room for this. I'm going to find a new home for this 18 by 24 surface plate, which is very nice, that a friend of mine gave to me. And this Brown and Sharp square here, which is very pretty. I will still have to find a home for that. Maybe I'll move it over there as well because it's too big to fit. Oops. A bunch of other places. Brown Sharp 540. Beautiful case for it too. I might make it live over there. In any case, this was a really nice addition to the shop. I'm very pleased to have it. Yeah, so I could fit this guy right here and it would be just fine. Yeah. Okay, that'll be great. That'll work. Because that thing's too big to fit a lot of other places. So, no drawers. Drawers would have been nice, but we went for quick and dirty. And I'm reasonably pleased. I just added a ton more weight. I had this thing all leveled up. I bet you now it's not so level anymore. Let's take a quick look. So you'll notice the vast majority of weight is on this left-hand side. And those bottom feet supports that screw down are plastic. So I'd expect it to drop a little, and hey, what do you know? It's actually went the other way. That's very, very surprising. I'm not quite sure why, but I'll have to tweak the feet. So the way I was adjusting this, rather than just sit there with a hammer and tap those plastic, sorry about that, you didn't get to see. So rather than get a hammer and tap these plastic adjusters in here, which are pretty inconvenient, what I've been doing is taking a jacking up the side I want to make the adjustment on, and then adjust the adjusters so they just touch, and then letting the jack down and see how close it is. That's a lot easier than trying to tap these guys into place, which actually ends up being pretty difficult. Yeah, I'm pretty curious because the vast majority of weight is on that side over there. So I would have expected this to dip down a little bit, but in fact, I need to raise this side a little bit. So that's very interesting. Well, we'll tweak that and see how it goes. I also have most of the weight in back, which is weird because it also went the exact opposite. The front needs to come up, and I would expect the front to be popped up and the back down, but they're both exactly opposite. Anyone has an idea why that happened? I don't know, but we'll get that sorted out, and then maybe we can figure out how to find a way to store this underneath temporarily, but for now, it's going to live on top. Next up, I've been meaning to address this exposed belt here on the belt sander, and I came up with an idea. I did some quick measurements, and I'm just basically going to build a simple cover that goes over it that'll be bolted down to the base plate here. And the way I approached it, since I don't have a brake that'll do anything this large, I came up with another solution that I'm not sure is going to work, but we're going to try it. So I measured everything out, and I've left a 1-inch lip on the bottom where I can screw this to the base. I'm going to use fairly thick material. I've got some 1/8 inch thick material here, and so I can't bend that anyways. Here's the two wings that are going to fold inside. They're going to go 2 inches folded in, and the top part folds down, and then a little piece folds back to protect from the back. And you'll just undo 2 screws, lift this whole thing up, and it'll be good to go. So we got some aluminum sheet, laid all that out, cut it out on the bandsaw, and got it close. It's not a precision operation. And now I've got to figure out how am I going to bend material this thick. What I'm going to try is I'm going to try and mill a V-groove down where the material is supposed to bend and remove all but, I don't know, maybe 50 thousandths of material, I'm not sure, 25 thousandths of material to allow a bend, make it easy to bend it, and then turn around and just add a couple weld beads to support that bend and see if that works. That's my solution. It may be a bad choice, but we're going to find out. Loaded up here, I have some of the same material marked off, and this isn't how I'm going to hold the other sheet material because obviously the vise wouldn't hold, it's way too big. What I'm going to try is this single lip cutter here. This came from China. It's a solid carbide. They've got some nice relief ground here. It's razor sharp. The only negative thing I see possibly with it is that this goes to a 90-degree point. And what I might want to do is flatten that off to give a bigger bend radius inside. But we'll see. We're just going to give it a shot. We're going to play with this guy. This is a 6mm cutter. And we're going to load it in my 6mm R8 collet. And we're just going to do some test runs and see how deep it needs to be for it to bend reasonably. And whether having the sharp point is a good idea or whether I need it to be a wider base so that it's got, like I said, a better bend radius. As I might have mentioned earlier, this material is 0.125 thick. So we're going to start with 50 thousandths pass, which will leave 75 thousandths of material, but I think that's going to be too much. I have this kind of high speed here. I'm not sure what to do this with. Let's try 1400. Well, that went very smoothly. So 50 thousandths depth of cut should leave 75 thousandths material, and it's still pretty stiff. Let's go for another 25 thousandths. At least 50 thousandths of material. I think my original target was to leave 25 thousandths. Yeah, it's still pretty stiff. Still feels tough. Let's leave 25 thousandths, see what happens. Let's see if we can bend that guy. Oh yeah, that bends easily. Hey, look at that! I can even get 90 out of it. All right, I think I'm buying that. I can't bend it back now that I've done that, of course. I think that's gonna be a ticket. Let's go another run here, a couple more, and see how it goes. I don't think I dare take it all at one time. Well, now that I bent this up, you're not going to be able to see it. But it bent really easily, and it looks like it's going to stay. Let's see if I can get this in a box. I'll bring it back. So I raised the RPM up and got a slightly better finish on that second pass. Both these are 2 passes. Single lip cutter leaves kind of a rough finish. The reason why I chose single lip was because it would be easy for me to modify it and get a flat bottom. Yeah, it's kind of making a mess of the sides. Higher RPM is better. I went up to about 2,000 RPM and got a slightly better finish. I think if I have to do again, I think I will shoot for a even higher RPM. So we'll give that a shot. So there's what the bends look like, and this length is very rough, so actually it's interfering. But looks like got really nice bends there, leaving 25 thousandths of material. So I think I'm going to go with that because I think that's going to work. If I just removed a little bit of material off here, I could fold it all the way. I removed a tiny bit of material. It looks like we can get better than 90 with the 90 cutter, which is a little bit surprising. I figured it would be a little worse than 90 personally, but well, that's actually pretty darn good. That one is tighter than 90, believe it or not. It actually should be open a little. And then I can go along and run a bead on the inside to strengthen this guy. So there you go. That one's not quite 90. I might have left some debris in there, but generally pretty darn good. So I think this might be a successful method if you don't have a large bending break and you want to get a really sharp corner. Probably nothing new, but it was an approach I thought of as a solution to not having a way to easily bend. So I'm setting up a square edge, and all I do is keep tapping it in, running the indicator until it doesn't move as it transitions from one side to the other. And we're maybe a tenth from edge to edge right now, which is far more square and straight than the piece of aluminum I've got. So I'm happy with that. So I've locked this guy down. So that gives me something to push the aluminum up against. Then I'm going to find my 0 right on this edge, and I can just measure. I can do 2 inches, I can do 1 inch. It'll make it really easy, and we'll just clamp the aluminum down to the surface here and just run my slots, and we should be good to go. All right, so I've got quick clamps on both sides of this plate. You can sort of see one over here. There's another one right here, which you can't see. This is my 0 point, so all of my measurements are either 1 inch from the edge or 2 inches from the edge, so this should be very straightforward. So we're just going to do one at a time, and what I do is I drop my quill until the point touches. That becomes my 0 roughly. If you need it to be more accurate than that, you'd have to do something else, because the point probably digs in, so it's actually probably a couple thousandths deeper than that, but close enough for this. This is not precision anything. Next up, I'm just going to plunge in, start with 50 thousandths, and we're going to power feed, and then we're going to come back and forth. I'm going to take off 50 thousandths first pass, then 25 and 25 as it gets thicker, and I'm just using this as my square, so push it up against that, come in an inch, and I can just tell where the line is. It's pretty straightforward, and we should be good to go. I'll try even higher RPM. Let's try 2300. So we're going to go down and cut. Seems like a very manageable speed. The quill just clears the square, at least when I measured it. I did a pass already, just a test pass. Yeah, I got about an 1/8 inch clearance, so that's good. Now this first one I'm doing here, the bend actually is going the opposite direction of all the other bends. So this one will be on the back, then I'll flip it over, and all the others will be on the front side. So I'm going to finish off these cuts and I'll bring you back. I know I've showed these before, but in case you missed them, these are these T-slot nuts that are quick nuts, and you can just stick them in, twist them, and they lock in place as they tighten. They're not as strong and more likely to damage your T-slots if you're putting a ton of force on them, but I'm not. So they're quick to go in and out, and you can get in between things rather than have to slide all the way back to one of the ends. All right, so here we are before bending. So this part's going to go up, and this part's going to go over like that. This part's going to go up, this part's going to go up. Opposite side, this side's going to go out. I'm going to drill some holes before I do that. And next stop, we'll be should have a cover if I measure everything right. I did screw up one thing here, I noticed as I was cutting this, because I got this all squared up, and this one right here, I cut this one off at the wrong point. It should have been about 1/4 inch longer. And wasn't cut perfectly square either. I can see even the angle here when I'm looking at it. So that's kind of unfortunate. Anyways, that was a screw up, but shouldn't prevent this thing from working reasonably well. So next step, welding and then fitment. As long as I have you captive here, I'll show you how I tram my vise. It's a pretty quick way that I learned from some gentleman. I can't remember his name. I wish I'd give him credit for it. So what I do is I've got the bolt on this side in and tight, fairly tight. And this one I'm just going to get finger tight on this side. And this becomes my pivot point over here because that's the tight bolt, this is the loose one. And I've got a precision parallel in here. And I'm just going to run the length. And as you're running the length, your goal is to stop the needle from moving. It doesn't matter where it stops moving on here, as long as you still have range, it just needs to stop moving. So if it's climbing, wow, okay. Yeah, it's slightly climbing. And with just a couple passes, you can get this guy zeroed in because you're adjusting the whole time. I find that it works really well. It's much quicker than doing a pass, measuring, doing a pass, measuring. Well, that tap was it. It's not moving at all. And with this particular parallel, I can get quite a range where I can see if there's taper in this, which there is not. This is beautiful. Holy cow. I'd need a tenths indicator to see anything, if anything. This did not move the whole way. All right, we are good. Just to make sure the indicator is moving. So then I just cinch it down. So you saw how quickly I got that lined up, just a couple passes. Instead of doing a pass and adjusting, doing a pass, taking a measurement, tap it, come back, reset 0, do a pass, take a measurement, reset 0, and iterate like that. This is much, much faster. You can get your vise crammed in. Now I have a little bit of an advantage because the Kurt vise has pinholes on the bottom, 5/8 inch holes, and those two pinholes line up with this T-slot. So I have the two 5/8 inch pins in there, or maybe it's 3/4 pins. I can't remember. I think it's 5/8. Anyways, the pins line up with my T-slots, and it's only off by a few thousandths at most ever, just putting it back. So that makes putting things back really quick and efficient. Here's my sample piece that I did tests on, and I bent it several times before it broke, like this guy right here. Although this stuff is very, very work hardenable, and maybe it's the wrong alloy aluminum if you're going to do bending. I know that the auto industry spend a ton of time and energy trying to figure out which metals bend easily without cracking and all the other issues that they can have, and they may have to anneal them afterwards. But this stuff, this is 6061, pretty darn fragile stuff. The weld worked out okay, makes it a pretty strong joint. My welding skills really suck. My tungsten really likes to live life in the pool. I guess it's Southern California tungsten. That's just what we do here. But the concept seems good. And let's go see how the final product turned out. All right, so here we are over here, and you'll see that there's some welding on the outside corner of this guy, and a couple of them, that's because there was some cracking after I bent it. This bottom one was the only one that I was able to bend the whole length without cracking the aluminum joint, the 25 thousandths of material left. So I don't know, I don't think thicker material would help. Maybe having a flat bottomed cutter would give more of a bend radius and make it less likely to crack. That's entirely possible, so we'll try that next time. But this is it in place, and it turned out pretty good. Well, possibly one more thing here. So this guy, this plate, it all worked out fine except for one little issue. Without a curve put in here, I can't get the sanding belts out. So I'm thinking about modifying this aluminum plate, although it looks like this guy's a little bit in the way too. We'll have to see. I'm going to try and cut this aluminum plate out with the semicircle here so that I can get the sanding belt off without disconnecting this. That will be a handy feature. I threw some Dicom on the inside of this guy, and this handy combination scriber that I've had since I was a kid, got from my dad. This is very handy for reaching in where you can't fit an ordinary scriber. There, I've got my cutout marked out. Hopefully we can translate this into a cut. You know, I could just freehand it too. There's always that. That might be easier than setting up a boring head, trying to get everything on center, or a rotary table. I don't know that I've ever shown my bandsaw set up for normal bandsaw work where you've got a fixed, although the throat width is really tiny here. I think it's like 15 inches. No, not even 15 inches, like 12 or 14 inches. Anyways, it's small. But you push the blade all the way forward, and then you use this little locking bit behind it so the carriage can't move, and then it's a regular bandsaw, and it works reasonably well. So I just cut out the excess material on here with that, and I'm going to finish it with a file, and we'll reassemble and see how it goes. Well, the bandsaw made super quick work out of it, and we're just going to remount it now and then see if I can still get the belt off. It's going to be really tight because one of the things about this vacuum attachment that I added on here was that there's not a lot of clearance on purpose so that the debris would automatically get sucked up, and it seems to be working really well. Other than that back corner back there, the debris doesn't seem to be going up the belt, which is really good news. It's keeping this much cleaner. So it's working, but it still has some, it's not perfect. So here's the final answer. Yes, I can get the belt out with a little bit of difficulty. It is not smooth. I would need more clearance on that bottom piece to make it really smooth, because right now it rubs on the way out, but you can get it out. You just got to keep going back and forth between top and bottom because it's wedging. But yeah, it does come out. So I can change the belts without removing that piece, but if I remove that piece, it'll be much easier to swap the belts. So it's sort of 6 of one, half dozen the other. That's only 2 screws to take that bottom thing out, so that might be the way to go, but now I have the option. Anyways, that was a good little lesson there. And here's the other side of the cover, and you can see protecting the belt on the inside from hands and whatnot. It's not perfect, but I think it's more than adequate for what I need. Anyways, thanks for watching. Hope you find it useful. Hope to see you next time.